Hello students, this is the video on QA topic tests which we at Bodhee Prep have for you. Now these tests are to be taken once you cover the basic concepts of a topic. There are multiple tests available in each topic. So you cover the concepts, you take the test and understand whether you're able to apply those concepts in a test or not. Once you've taken a test, there is a video with every test which gives you the solutions for all questions and also an analysis of what would have been a good attempt for that kind of a test in the real exam, the kind of time that you should have put for questions. There are more than 200 such topic tests available on the Bodhi Prep Android app. The link for the app is in the description below. So make sure you download the app and make the most use of these tests. This video is on the topic linear equation. This is test number 4 on this topic. Overall, the test was probably moderate level of difficulty, and for a 95 plus percentile, you would look at 6 to 7 questions net correct, and the attempt time would be somewhere around the 20 to 22-minute mark. If we do look at the questions, when David stands on a stool, he's 5 inches taller than Kathy, standing on the floor. When they switch positions, Kathy is 23 inches taller than David. So basically, David plus stool is 5 inches taller than Kathy. If the height of David is D, the height of the stool is S in inches, and height of Kathy is K. Uh, David plus stool is 5 inches more than Kathy. Whereas if Kathy stands on the stool, so K plus S is 23 more than David. Add the two equations. K plus D plus 2S is equal to 28 plus D plus K. D and K get cancelled out, and therefore S comes out to 28 by 2, which is 14 inches. How high is the stool? 14 becomes the answer. Or we don't have to write the equations. We can all say that when the stool goes from David to Kathy, the height of David decreases by the height of the stool, and the height of Kathy increases by the height of the stool. So the difference is 2S. D loses S, K gains S, and because of that, the overall difference is 23 minus 5, which is 23 minus 5, which is 28. We can directly write this equation as well. Again, I think maybe a moderate question at best. Uh, the writing the equation might seem a little bit tricky. Otherwise, once that happens, it will not take more than maybe a minute and a half to solve. How many ways are there to provide $10 if one has as many 5, 2, and $1 bills as needed? Now, one is we have 10 $1 bills using single notes, or 5 $2 bills, or two $5 bills. So this is one way, two way, three way. Now we can combine. If we are combining $1 and $2, we can have 8 $1 bills plus one $2 bill, or 6 $1 bills, two $2 bills, four $1 bills, three $2 bills, two six four two $1 bills, four $2 bills. Beyond this, again, either one will become zero, for which case you already counted. This is using 1 and 2. If we combine 5 and 2, we can never have $10, because 5 plus 2 plus 2, then we will need 1. So 5 and 2 case is not possible. If you look at 5 and 1, we can have one $5 bill and five $1 bills. So that can be one case. All of these are individual cases. So we look at $1, $2, $5 bills individually. We look at combinations of 1, 2, 1, 5. 2, 5 is not possible. Also with 1, 5, only this combination is possible. Then we combine 1, 2, and 5. So we have one $5 bill. So $5 are left. That can happen with three $1 bills plus one $2 bill, or one $1 bill plus two $2 bills. So these are the cases possible: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hence, 10 cases are possible. In just to avoid confusion, this is dollar, this is dollar, this is dollar, this one is dollar, here two is dollar, here one is dollar, five is dollar, $5, dollar, dollar. The other is the number of bills of that kind. So this becomes the cases. Again, moderate level of difficulty. Attempt time might be a little on the higher side because we are counting individual cases. So yeah, 2 to 2.5 minutes to solve. Angela and Fred bought 4 presents for various weddings, but they couldn't agree on 4 identical gifts, so they bought 4 separate gifts. The gift cost the first gift cost $5 more than the second. The second gift was half the cost of the first plus one third the cost of the first. So if the first one cost X, the second one cost half of X plus one third of X. X by 2 plus X by 3 will become 5X by 6. It is also known that the first gift is $5 more than the second gift. Therefore, X is equal to 5X plus 6 plus 5. This means taking it here, X minus 5X by 6 is equal to 5, which means X by 6 is equal to 5 or X is equal to 30. So the first gift costs $30. The second one is 5 by 6 of 30. 6 5 are 30, $25. The third gift costs two-thirds of the first gift. So the third gift will be 2 by 3 of the first, which is $20. And the fourth gift cost double the third. So fourth gift will be 2 into 20, that is $40. What was the cost of the fourth gift? 40 becomes my answer. I think basic linear equations, easy question. Since there are four values, the time might go up to about 2 minutes, but overall easy question. In a pen of chickens and goats, there are 40 heads and 130 feet. How many chickens are in the pen? If the number of chickens is C and the number of goats is G, we can say C plus G. Each of them has one head, so that is 40. Each chicken has not heads but feet, and each goat has 4 feet. So 2C plus 4G is equal to 130. Number of heads, number of feet. We want to find out the number of chickens. So what we do is we multiply this by 4. So 4C plus 4G is equal to 160. Take this equation, subtract it from the first one. So 4C minus 2C is 2C. 4G cancel. 60 minus 130 is 30. C comes out to 15. Number of chicken is 15. This is one way of doing it. The second way could be where I don't write the equation, but calculate it directly. That is to say, each head will have at least 2 feet. So out of 130, 50 feet are left. This will be because of the number of goats. Because goats have 2 extra feet, and therefore number of goats will simply be 50 by 2, which is 25. Subtract that from 40, we get the number of chicken as 15. This could be the third way. The idea here is each of the heads will definitely have 2 legs per head. So 80 is accounted for. There are extra 50 feet. These 50 feet is because goats have 2 extra feet apart from the 2. So number of goats becomes 50 by 2. This could be the second way. The third way could be that we simply aggregate. Here the number of feet per head is 130 by 40, which comes out to 13 by 4, 6.5, 3.25. Now the feet per head of a chicken is 2, feet per head of a goat is 4. And in our mixture, it is 3.25. So if we aggregate, the difference here comes to 1.25. The difference here comes to 0.75. Dividing by 0.25, we get 3:5 is the is the ratio of the number of chickens to goats. 3/8 of 40 will be 15, and that could be my answer. Each of the three ways will not take more than, I think, 90 seconds, no matter how you're doing it. Easy question. A coin purse contains a mixture of 15 coins in dimes and quarters. Now, dime is 10 cents. That is 1/10 of a dollar. Quarter is 1/4, 25 cents. The coins have a total value of $3.3. Determine the number of dimes in the purse. If the number of dimes is X or number of dimes is D and the number of quarters is Q, D plus Q is the number of coins, which is 15. Each dime is 10 cents, so 10D. Each quarter is 25 cents, so 25D. This will be the total number of cents in the purse, which will be $3.3 becomes 330 cents. We are solving for D. So what we do is we multiply this by 25. 25D plus 25Q is equal to 15 into 25. 15 into 25 will be 10, 25 is 250, 5 into 20, 125, add 375. Now subtract this equation from this one. 25D minus 10D is 15D. Q and Q cancel. 375 minus 330 is 45. And therefore D is equal to 3. So number of dimes in the purse is 3. Again, dime might be a problem. Otherwise, easy question, not more than a minute and a half to solve. Here we could also use allegation. If we look at the value of each coin, in this case, it is 330 cents upon 15 cent per coin, which will be 22. This will be the allegation of the value of a dime and a quarter. The difference here is 3, the difference here is 12. 3 plus 12, 15. So 3 dimes and 12 quarters will also be my answer. Tammy's age is the sum of ages of Carmen and Dennis. Carmen's age is 2 more than the sum of Dennis and Mark. Dennis's age is 4 times that of Mark. Sum of all the 4 is 42. How old is Tammy? Now Dennis and Mark. Dennis is 4 times that of Mark. So if Mark's age is X, Dennis's is 4 times of that, so 4X. Carmen C is 2 more than the sum of Dennis and Mark. So 2 plus X plus 4X. That is 5X plus 2 is Carmen. And Tammy is sum of Carmen and Dennis. So Tammy will be sum of Carmen. 5X plus 2 plus Dennis, which is 4X. Therefore 9X plus 2. The sum of all of them is 42. So X plus 4X plus 5X plus 2 plus 9X plus 2. This will be 42. 9, 5, 14. 19X is equal to 42 minus 4, 38. So X comes out to 2. So M, Mark's age is 2, Dennis's is 8, Carmen is 5 2s are 10 plus 2, 12, and this is 18 plus 2, 20. What is the age of Tammy? 20 becomes the answer. Again, I think straightforward sort of a question. Shouldn't take too much time to solve. Basic small numbers and therefore easy. At max 20 minutes, 120 seconds to solve. On Jan's ranch, they clone both sheep and cattle. Unfortunately, sheep end up with 2 heads, cattle with 6 legs. So here the sheep have 2 heads and 4 legs. The cattle has 1 head and 6 legs. A field contains both sheep and cattle. If there are a total of 38 heads and 100 legs, how many sheep are in the field? If the number of sheep is S, number of heads will be 2S. And for cattle, number of heads will be C. Number of cattle is C. This is equal to 38. For sheep, the number of legs will be 4S. For cattle, it will be 6C. This is 100. We have to find the number of sheep. So what we can do is, we divide this by 2. 2S plus 3C is equal to 50. Take this, subtract from here. 2S minus 2S, 3C minus C is 2C. 50 minus 38 is 12. So C comes out to 6. If you put C here as 6, 2S plus 6 is 38. 2S is equal to 32. S comes out to 16. And therefore, the number of sheep is 16. We would not use allegation because here legs per head, if we calculate, we get a number which has 19 in the denominator. So allegation will not be a very efficient method here. But what we can do is we can say, in this case also, for sheep, for example, each head has at least 2 legs. Here 2 heads have 4 legs. So per head there is 1 leg. And here one head has 6 legs. So at least 2 legs are there. Therefore, 38 heads will account for 38 into 2, which is 76 legs. There are total 100 legs. So there are 24 legs extra. Why are there 24 legs extra? Because here one head has 2 plus 4 extra legs. and therefore the number of cattle will be 24 by 4, which is 6. And from there we can find out the number of sheep as 16. Again, maybe because the numbers change, therefore I'm saying moderate, but should not take more than 2 minutes to solve. To attend a math contest, a team must pay a fixed registration fee. If there are 4 more members of the team, the price per member. Let the number of team members initially be X. Number of members and price per member be Y, rupees Y, dollars Y, dollar Y, dollars. Therefore, the registration fee is XY. If there were 4 more members, so the number of members becomes X plus 4. In that case, the price per member would be $6 less, or Y minus 6. X plus 4 into Y minus 6 should be equal to XY, the original registration fee. On the other hand, if there have been 6 fewer members, X minus 6, on the team, the price per member would have been $14 more, so Y plus 14. This also should be equal to the registration fee, which is XY. Now we try to solve this and get equation X and Y. If we open the brackets, on the right hand side, we get xy plus 4y minus 6x minus 24. Xy cancel. And therefore, 4y minus 6x minus 24 is equal to 0. Here, xy is equal to xy minus 6y plus 14x minus 84. Xy cancel. So, 6y, 14y. 6y plus 14x minus 84 is equal to minus 6y. We had how many members in the team? We're trying to find x. So what we do is we first divide this by 2, then multiply this by 3. So 2y minus 3x minus 12 is equal to 0. Multiply by 3. 6y minus 9x minus 36 is equal to 0. This is equation 1. This is equation 2. Adding equation 1 and equation 2. 6y minus 6y cancel. 14x minus 9x is 5x. Minus 84 minus 36 is minus 120. Which means 5x is equal to 120 or x is equal to 24. How many members did the team have? The team had 24 members. I think this question for me would be, again, because the equation is simple and the xy term cancels out. So I'm saying moderate, but as compared to the other questions in this test, this would probably be till now the most difficult question of this test, and therefore attempt time would be about 2.5 to 3 minutes. What is the value of z in the solution of x plus 2y plus 3z is 7, 2x minus y plus 3z is 14, and z is equal to 2y. Substituting z, here we get x plus 2y plus 3 into 2y is 7, which means x plus 2y plus 6y is 7, which means x plus 8y is 7. Substituting z here, we get 2x minus y plus 3 into 2y is 14, which means 2x minus y plus 6y is 14, which means 2x plus 5y is 14. If we multiply this by 2, 2x plus 16y becomes 14. This is equation 1, this is equation 2. 1 minus 2, 2x cancel, 16y minus 5y is equal to 14 minus 14, 0. Which means y is equal to 0, which further means z is equal to 0. What is the value of z? In this solution, z will be 0. I think easy question, just solution of a set of 3 linear equations with 3 variables, and the calculation is also not very difficult because the numbers are pretty small. So about 1.5 to 2 minutes to solve. Dan has some coins totaling $5. If he has only nickels is 5 cents, dimes is 10 cents, quarter is 25 cents. The number of dimes is 11 less than twice the number of quarters. The number of nickels is 25 less than thrice the number of dimes. How many dimes does Dan have? Suppose the number of quarters is X. The number of dimes is 11 less than twice the number of quarters, 2x minus 11. and the number of nickels is 25 less than thrice the number of dimes. So 3 into 2x minus 11 minus 25. This comes out to 6x minus 33 minus 25 or 6x minus 58. The total is $25. So the value of quarters will be 25x. The value of dime will be 10 into in cents, 2x minus 11. The value of nickel will be 5 into 6x minus 58. This is equal to 500 cents, $5. 25x plus 20x minus 110 plus 30x minus 290 is equal to 500. Uh, 25, 20, 45, 30, 75x minus 12, 300, 400 is equal to 500. 75x is equal to 900 divided by 75. X will come out to 12. So number of quarters is 12. Number of dimes will be 2 into 12 minus 11. 24 minus 11, which is 13. And number of nickels will be 3 into 13 minus 25, which is 14. How many dimes does Dan have? Dan has 13 dimes, and that becomes my answer. Again, nickels and dimes might be a problem. Otherwise, not a very difficult question to solve. So if you look at the overall test, at best a moderate level of set, because there are a couple of questions which might end up wasting time. Otherwise, we're looking at least 6 to 7 questions net correct in about 20 to 22 minutes. If I had to choose my 7 easy questions, for me, they would be 3, 4, 5, 6, 7, 9, 10. Which are these? I am not counting this because there might be some confusion while solving. Again, since you're counting the number of ways, there is always a chance of missing out on number or over counting. So not counting this as an easy question. This is a straightforward equation, linear equation. We'll attempt this always. I think we've done such kind of questions many times to be able to attempt this. Similarly, basic equations, attempting this question as well. Here also basic values, so was able to attempt it because the numbers are also small. This is a similar question like the fourth one, and therefore would have attempted it. Here, calculations might be a little longer, and again, not the easier of the 7, or the easiest 7 of the 10. So not attempting this, not counting this as an attempt for sure. This again was a simple calculation, so yes, an attempt. Similarly, this one have done enough questions like this to be able to solve it now, and therefore 3, 4, 5, 6, 7, 9, 10 would give me my sure shot 7 attempts.